if we live should be fine, but worth to double check all the time.
Yeah, and if
How
we are,
how is your morning, Igor?
my morning is perfect. I just woke up and we try to speak Dutch and German to each other. So I feel good. I feel good. How are you? Some people say that you already had a very active morning.
Yeah, true, very true. I already had the football training in this morning, so
Impressive.
already tired. So that's good for morning, Saturday morning, right? That's how it should be.
Yeah, probably, probably.
Yeah.
That's how it
And
should be.
Igor, you're gonna be on vacation in the next week, so we decided to connect today. Have one of the design sessions, like a few last times,
Yeah.
right?
Yeah, so I guess it's gonna be also very impressive, like it was two last times.
Yeah, but actually, I read yesterday a few articles about how to prepare yourself for system design interviews, and
Mhm.
yeah, I think few observations. I think what you did on the previous ones was in a lot of things already. I mean, functional requirements, non-functional requirements, user stories. I hope we will see that today as well. But I mean, it was already a big part of what is expected in these kind of interviews. So that's a good sign overall. And
Mhm.
one other notice that I have is that they suggest to train. So that's what we do, and that's what we are doing today, right?
Yeah, for sure. No, training is important, the most important. So yeah, let's have kind of this session today, and maybe we can do it very interactive. So it's not that I'm doing
Yeah.
only the stuff that I can do, and then you say it's good or not. But let's probably go together.
Mm-hmm.
You guide me
Yeah.
on the way.
Exactly. Let's do that. I have three topics that I wanted to propose to you. Two are more
Mhm.
technical, sort of, and one is a more traditional thingy. Um, Let me begin with a technical one. So I
Mhm.
thought, okay, maybe we should build online market website. And
Mm,
it's a silly task, but yeah, sort of well known, and I mean you can train your skills there as well. But then I thought, yeah, it's too still.
easy.
Actually,
Okay.
actually, maybe to build something like a constructor of such websites, like things like a Tilda, like a Wix editor, like a website constructor thingy. So that's
Mhm.
option one. Option two, let's put it more traditional. I think I already proposed it once, but I really like it. So this is a LinkedIn like site,
Mhm.
LinkedIn like application. I mean, we can focus on any areas of this huge ecosystem.
Mhm.
And the third one, maybe it's even more interesting to you, and I know you have some experience with these things already. So this is a sort of a news aggregator. So what we want to do in the option three is like to crawl, if you want. We can also store information from the top news resources, and then we want to aggregate it somehow. Yeah,
Mhm.
think of those. So those are three options for the Saturday morning.
These are great options. Um, yeah, I don't know. Probably I would go with a LinkedIn. Uh, I don't know why. The first one sounds like really complicated to me. I mean, they all seem really complicated to me. So I would go for the second one. But so what's your take?
Yeah, sounds good. I mean, also interesting to me. Yeah, the
Mhm.
end is gonna be huge, so we can focus on any things there. Yeah,
Yeah,
it includes a lot of options. I mean, the original application itself, so we can focus on anything.
yeah. That's also actually part of the interview, how to narrow it down to something. smaller.
Yeah, exactly. And the guys say that there are no wrong options, no wrong answers for these interviews.
You know, I know some different information. But yeah, maybe these guys are right. So, okay, so we have let's build a LinkedIn system.
Mm-hmm.
Good. So I guess we should start from defining what exactly we want to build. So as you said, LinkedIn's a huge system, and
Usually people
now
start with a title, with a name, and then and then also already book domain name and buy it for like 10 years upfront. That's is that something we want to start with?
you mean that we have to book the URL to go?
Yeah, I mean it's
Yeah,
logical, right?
yeah, and we should do it in every country, so not only .com but also
Mm-hmm.
.org.us or UK.
Mm-hmm.
What is
Yeah,
the domain
sorry for
for
that.
Netherlands?
NL.
NL. Oh yeah, exactly. NL.
Mm-hmm.
LinkedIn.nl. Perfect. Yeah, that's a good idea. And then we have to think of what our service provides to the customer, right? So I think
Mm-hmm.
initially it was just for people to find a job. So maybe you upload your resume, and then the employers can upload the job descriptions, and then the service was matching them. I honestly don't know how it started, but maybe one of the maybe I could write it somehow. But yeah, I like this color. Okay.
Mm-hmm. Yeah.
So job matching service. So that's kind of one of the I don't know user stories or I don't know missions of the website.
Yeah. Key features or something like that. Yeah.
Yeah.
Mm-hmm.
Okay, pictures. Yeah. Also now it serves as a social network. So there is like a news feed,
Yeah.
which is yeah, which gets a lot of time from my week. Unfortunately,
Yeah.
there's almost
Yeah,
never
I
anything
like actually
interesting.
social network is a bit broader, but I think if we're talking about key features, we should put it there, not only newsfeed, but like a
Mhm.
social network.
Yeah, social network. Yeah, because you can write posts, you can network, you can connect with each other,
Yeah.
follow, yeah, comment and whatever. Yeah, and you can do all the things. Also, yeah, they have the capabilities for doing recruiting. I'm not sure if it's a separate
Mm-hmm.
feature. Maybe
Mm-hmm.
recruitment uh, features. So you can use it like to track candidates, to arrange the
Yeah.
interviews, and all these things.
Mm-hmm.
Um, Maybe these are the main features of LinkedIn currently.
Yeah, I think so.
Yeah, yeah, and I guess for us it will make sense to focus on maybe on one of them, or yeah, at least start with one of them.
Yeah, I agree.
Yeah, so I would say maybe the job matching service is the most
Mm-hmm.
straightforward,
Yeah.
how it was initially
Yes.
done.
Yeah, because social network can also less less concrete. Let's say social network can be in Instagram, in Facebook. So
Hmm.
yeah.
Yeah, totally. Yeah, and okay, so let's say now we're building a job matching service, and that means that yeah, I guess we should again start from functional requirements.
Or user stories, like
Mm,
what exactly we want to build. I mean,
yeah,
it's
user
fine, of
stories.
course.
Yeah, functional recs.
Mm-hmm.
Okay, so as a so yeah, there are two like sides of this. So there are candidates and there are recruiters. So for the
Mm-hmm.
candidates, so the first thing we should be able to upload our resumes. Then if we're recruiter, we should be able to create job descriptions. And then there is matching service, and I guess it should work in 2 directions. Not sure if it's a different service. So I mean, for the candidates, it should show the best, the most fitting job descriptions, and for recruiters, it should fit the most. Should show the most fitting candidates. Yeah. Yeah. What do you think? Should we separate it, or we can just?
Yeah, I mean, we're talking about the user stories, not about services now yet. But yeah, I see what you're saying. We can make multiple. Let's try to minimize the amount of user stories. So.
Okay, yeah. Let's look at it from the candidate perspective. As most of the people are candidates, so show the most matching jobs to the candidates. What else? What are the user stories? I mean, being able to apply, I guess, is a user story.
Apply, yeah, sounds good. Apply and search and apply, maybe something like that.
Yeah, actually, yeah. Search, job search, and job application. Yeah, I guess we could maybe. Oh no, what happened? Okay, I'm here, right? Yeah.
Where is our name of our?
Yeah. What? Oh, what the?
Oh.
It's magic.
Can reload the
Yeah.
service,
Okay.
maybe.
Yeah. Perfect. Yeah, we have some user stories. Yeah, then as I watch these videos, then people just usually jump to non-functional requirements, and I could also try to do them. I'm also always like a bit hesitant to do it because to me they always look the same, like always non-functional.
Yeah.
Like it should be fast.
Shouldn't
Should
be
be
though. I mean,
reliable.
it can be very slow, right? Like you just relax there and like slowly
Yeah.
search it and wait a couple of minutes, maybe get a
Okay,
coffee.
not too fast.
Nice coffee.
We like coffee, yeah. We like coffee, yeah. So not too fast. So if it loads for 10 seconds, it's okay. For 1 minute, I'm not sure. Then about how it's called, consistency or okay, reliability. So maybe we don't need it to be super reliable. We can, if it broke today, no, yeah. I mean, it's good, not good that the service broke, but not too reliable. I like these functional requirements. Like 1 hour a day is fine.
Be careful. I think LinkedIn hire managers already watching us, and you are in a list. Like, yeah, this guy. We need this guy. Not so fast, not so reliable. That's what we need.
Okay, maybe 2 hours. Okay, let's make it like this. 2 hours. How to move it? 2 hours. Yeah. Then about the consistency, non-functional. What else of non-functional requirements are there? Like speed, reliability,
Number of
consistency
users, I
of
guess.
information. This is also a part of non-functional.
Let me check. I have a few articles actually open here.
Because yeah, we can calculate a bit of numbers. Maybe we can do it like here.
It seems that this is normal for the interviews. I mean, how can I tell you if that's correct or not? Probably I cannot.
Yeah, but you're right. Yeah, maybe we could. Yeah. Anyways, non-functional requirements don't make sense to me. I'm not an engineer. So we can calculate some numbers. And let's say we have some amount of active daily users or daily active users, and let's say we're big and we have 10 million daily active users. That sounds okay. Then what else? Maybe we could say what one user is usually doing there. So maybe one user performs maybe 5 to 10 searches. Let's say 10 searches per user. And then one user does like 2 applications. User does 2 applications. So for now, I guess we started to look at it from the candidate perspective. Yeah, so user goes to the website, searches, applies. What else? Maybe for now.
An offer, not an offer, but a proposal, like a message from recruiter to meet.
Yeah, actually, maybe this should be a user story. So some messenger is too complicated. Stories.
Invitation, some message system, maybe not a messenger, but indeed, like actually, it can be also done with the emails.
Yeah, it could be done. Okay, yeah, get the invitation in some form. Yeah. Okay, user does 1 application, 2 applications. Users, okay, the user. How these numbers might be useful for us. Ideally, we should like calculate some load on the system based on these numbers.
Yeah. Like we ideally, indeed, we should design something that would match what we predicted first.
Yeah, and I mean, if we just multiply 10 millions of users by, let's say, so it makes us around 15 actions per user a day. Let's keep it, 10. It's easier to calculate.
I see you use Grammarly. Okay.
Yeah, I'm using Grammarly. It's a nice service. It's not an ad. They don't pay us. Yeah, it would be nice if they do. Okay, so 10 actions per 10 million users. So it means we have 100 million actions per month, which doesn't sound a lot. Oh, wait, per day, which sounds a bit more.
I think I read yesterday Instagram design article, and they sort of they made a conclusion. Okay, like this is amount per day, and then they said for 10 years it's gonna be this space on this load needed, and then I don't know what expectation it gives, but
but right. And I think that leads us to 1,000 actions per second, more or less. If I'm not mistaken, because like the day has 86,000 seconds or so, 100,000. Thousands, millions, 100 millions. So if I'm not mistaken, it's like 1,000 actions per second, which doesn't sound a lot. Yeah, and you're right. So these are kind of some actions, but also we need to think of the memory, right? So what do we store? We store storing resumes, job descriptions, some messages. Messages could be applications or invitations. Yeah, and I guess we should also say maybe. Yeah, it's now a bit hard for me to say. So let's say we have. So for job for resumes, we need to know like the total amount of users of the service, right? Because all of them have resumes, I guess, and maybe a couple of them. I don't know. We can say 1 billion different resumes, or
yeah, only 1 or 2 per user with the versions of it.
yeah. So yeah, because daily active users, it's something different. Okay, we can say 1 billion maybe resumes, and we can say that plus I don't know 100 million per year, something like this. I'm not sure. 1 billion resumes per year.
I was calculating actually the previous one, actions a day. Looks like it should be much less. Maybe I'm mistaken somewhere. Oh,
Maybe you're right.
Yeah. Yeah, that's what I calculated indeed.
Is it?
Oh yeah, no, it was my mistake, I think now.
I think it should be mainly like this, because it's 86 blah blah blah. I don't remember exactly.
Okay. Sorry for that.
No worries. Yeah, so resumes per year. Yeah, I don't know like what's the typical weight of one resume. I think we should restrict it to maybe 5 megabytes.
Yeah.
5 megabytes per CV.
Sounds reasonable.
And that means that we need like huge amounts of storages. Oh, actually not huge. So yeah, and okay, it's 5 megabytes per CVs, and job descriptions and messages. I don't know, maybe we have much fewer amount of descriptions, like maybe like this. Descriptions per year. Oh, why per year? Yeah, okay, per year. And maybe we can restrict it to 1 megabyte, because usually there are no photos. Or yeah, why so unfair? Let's do it as well. Per description. And messages.
How do you count this 100 millions plus 10 million? Can you explain this one more time?
Yeah, so I mean that currently maybe we have 1 billion resumes already uploaded, and then we expect that every year it will be 100 million.
Growing,
and here
maybe.
I just divided by 10. Yeah, and yeah, messages. Well, I guess so. If you have 2 applications per user per day, that's 20 million messages per day. So 20 million, maybe times 2 at least, like 2 messages per application. So it's already 40 million per day. Oh my god. And maybe, so this will be per year, 20 billion messages per year. Okay, yeah, so let's say we already have like 10 billion messages, and every year it's plus 1 billion messages. And let's say one message should be small, right? So 1 kilobyte, no, maybe a bit more. And 10 kilobytes.
Yeah, 10, maybe even 100, but no, the 100 it's just huge. No, 1 kilobyte is okay.
Yeah. Well, yeah. So let's see. So now we need. So what storage do we need now and every year? Now we need 1 billion times 5 megabytes and times 5 megabytes. I'm pretty sure we are going too slow and doing something which we shouldn't dedicate so much time to.
No, to
So
me,
okay,
it's
yeah,
all a new experience. So I don't know how fast we should be in that. To me, it's all still artificial. But yeah, I think it's a good practice anyways.
Yeah. Okay, so if we have megabytes, if we, oh my god, billion, yeah, megabytes, gigabytes, terabytes, what goes after tera?
Peta,
Peta, exa,
petabyte.
petabyte, and then exa.
I will Google.
I think it's enough. Yeah, I think it's enough. We could stop at petabytes. Yeah, so it means
Exa.
so it means 5 petabytes. Is it written like this? PB. So it's a huge amount of. Yeah, now I'm just thinking. So why do we need to talk about it even? Well, we can say okay, yeah, we need 10 petabytes of data.
Yeah.
Don't have to access it always, right? So because for today work, we need to access some relevant jobs, and it will be important on how many like machines or services we need to have running. And I already said that. So there are 10 million daily active users, and we can say that daily active resumes. Let's say there's 1 million resumes. So that means that we need to store 1 million times 5 megabytes, 1,000 million. So it's megabytes, gigabytes, terabytes. Yeah, okay. So it's 5 terabytes of data, of resume data, and daily active 10 times less. So it would lead us to 0.5 terabytes of data, amount of data. Yeah, so that means that every day, how can I move? Yeah. So that means that every day we need to store around 5 or 10 terabytes of data, and all this data should be accessible. And what is the best way to split all this data for terabytes? Gigabytes. Yeah, I mean, it doesn't sound like an awful lot. I think terabytes could be stored in many different ways. And yeah, so what is actually the type of the usage of this data? So probably it's mostly used to read the data, right? Because we upload the resume only once, and then we might read it for hundreds of times.
Yeah, I agree. Yeah.
And the same, so it's DBs mainly for read, not write. And yeah, I saw some articles. They usually use this system when there is like one main DB where you can write the information, and then you create replicas of this DB and you read from these replicas.
Yeah.
Yeah. Yeah. So I'm not sure if we like main DB for writing, then some replicas as for reading the data. Yeah.
Yeah,
Maybe
I was
yeah.
a little focus on what you said. I remember there is a term CQRS, like a common query responsibility segregation. I think it's related to this. Yeah, basically splitting database for reading and for writing for different purposes.
Oh, actually, I haven't heard about it. To do. Yeah, I will read about it. Nice. Yeah. So I don't know. We can. Yeah, I mean, I can draw a couple of those, but I'm not sure if it makes sense. So kind of this
Yeah,
is
according to
the main
the guides, indeed, this is a next step, like a high-level design of a system.
Yeah, okay, even maybe,
Mhm.
yeah, maybe high level. So there is the user, and the user uploads the, can I write in here? I can. So user uploads the resume to main.db, to the main.db where the resume is stored.
Mhm.
Then this then this resume is copied to,
I mean,
I don't
to
know, we
me,
can
replica maybe is not it's not the exact word. I don't know if you agree or not. Like replicas should be always part of a database design. I'm sure, but in our case, it's kind of a split database. It can be just a database close to the main one. Main is for writing, yeah, that's clear. And then we have another database, which is not necessarily replica. Maybe it's already aggregated information from this.
Okay, yeah. Yeah, okay, we can say that it's a DB for it. Maybe actually then it makes sense. So it's a user, so the user could be either a candidate or recruiter, and they once send the data, so either a CV or the job description to the main DB, and then there are some databases. Maybe we can say database for it, for CV read, and then there should be a similar one for job read. Yeah, and there should be some connection from here to here. So yeah, you're right. Maybe they aggregate it in some way.
Mm-hmm.
Yeah, and then the user can retrieve the needed information. Maybe there is some service. I don't know, front-end service.
Yeah, I mean, I'm trying to go through the guide in the same time. I think it's not about the services yet. So for now, maybe just indeed read it. I mean, sorry to interrupt. It all makes
No,
sense, of
it's
course. What you're doing.
no, it's better if you do interrupt. So you mean it's better to just leave it so like this, or?
Sure, if you want to already in like the system in terms of services that we're gonna have, or just you just want to draw an arrow somewhere, let's say.
No, actually, I would like to do it like as it's nice to be done. So like first draw something high level, and then start digging deeper of what it could be. And yeah, I don't know like what is level.
Me neither.
Yeah, so
No,
so
no,
kind of
it's all right.
yeah. So it's in here. So I guess yeah, there should be some incoming services and some front-end services. Yeah, it all makes no sense to me. Like front-end service, back-end service.
No, it's. I think we should. This is what we wanted to do at this step. Yeah, maybe we could. Yeah, I see in the article they use like databases separately, and then you have something in between. Basically, we don't care what is in between right now. So that's how user interacts to something that is actually our system, and then we can go deeper to this system. And the system actually connects to the databases that you already drawn. Yeah.
You mean something in between here, or?
Yeah.
Yeah.
For both sides, sort of for input and for output.
Yeah, that makes sense.
Arrows doesn't matter. Yeah, I mean, sorry, it's all right. Yeah.
Yeah. Okay. Yeah. So more arrows and perfect. Yeah, I love drawing arrows. So yeah, some incoming, some outgoing service, whatever. And what can we focus now? I mean, what we can probably talk a bit about what is the design of
In
the
that
tables in
place.
this database.
Yeah.
Yeah.
Hmm. Yeah, I
Okay,
think makes
so
sense. Models.
oops. No, I want a new one, please. Thank you. Yeah, so main DB. Yeah, it always like okay, main DB for jobs. I mean, here we just like list of what data we need from the user to upload, right?
Yeah.
Or they do something smarter because okay, we need some user ID, we need some timestamp.
User ID for a job. What? Or it's a user table or some. Or what we're talking about.
Uh, okay, so user yeah, so job table we no yeah by user ID I meant so like the recruiter ID. So who did upload it? And by recruit ID, we can aggregate it with some tables and know what company it is. So when it was uploaded, and I guess the content. I mean, we can of course have some other information, but to me this is the main data. Maybe like some I don't know version. Yes, we can change it. Version ID. Yeah, but it's maybe small details. And the same probably will go for
CVs. Yeah.
for CVs. Yeah, CVs. So here will be the customer ID, timestamp when it was uploaded, so the content itself. The content actually may be some link to the file if they upload, because we didn't talk about how to store all of this. So if our service is pretty small, we can probably just accept files, like we just store files. So then we can say maybe URL or CRLs. And
Upload the file and CV URLs don't match too good, right? If you upload a file, then it would be in our system.
But how to say then? I mean, internal URL. Kind of, so yeah, there is some. So when user goes.
So you want to store the original file in a database, original user file.
I was thinking to store it on some file storage, and in the database just have the link to this file storage.
Okay, I see.
Because I mean, otherwise we need to either parse the original file and store it the content, or we can actually don't need to go that deep, or we can say just content and then yeah. And then yeah, probably first of all version ID, but also one customer might have multiple resumes, so we can say something like resume ID.
Oh.
Yeah.
Yeah, actually, both tables should have a primary key. Yeah.
Yeah, like job ID. Yeah, job ID, customer ID. Yeah, I mean they are super similar. Looks nice, I guess.
Yeah, not bad. Yeah.
Not bad. Yeah. Pum pum pum. Oh no, that's not what I wanted to do. Okay, so.
Yeah, at this point, I don't know. It doesn't make sense yet to discuss like sorry, how is indexes? I think we don't know yet what the functions we want to focus more. But maybe speak a little about the databases that we might use for that, like NoSQL, SQL, whatever.
Yeah, so So I guess the main DB and DB for read might be different ones.
Mm-hmm.
And so generally this one could be just a transactional SQL, so like error relational database system.
Mm-hmm.
So a usual one. So we send transactions and it just stores them. So I don't know, PostgreSQL or even MySQL, maybe if it's not too many data points. For reading, we need something maybe different. Actually, yeah, I mean, we're not gonna change the data very often, so we just put a transaction in the database and then we just read. So in terms of the type of the data, it's relational data. It's kind of structured, so we need SQL, I guess. And for fast reading, actually, we didn't really calculate how fast we should read, or did we?
We said some actions per day.
Yeah, searches per day, actions. Yeah, so we said so 15,000 or 1,500 actions per second. So that's for job search. I guess that's not a huge number even for typical databases like Postgres, so we don't need anything specific. But probably we need some replicas of them. I don't know how we call it. Some different instances which store the same data, and the requests are sent to one of them, just to reduce the load on all of them.
Yeah.
Yeah.
Okay. Now it sounds good actually at this point. Yeah, I don't know if you have any idea on. Or maybe it's not that right time to like discuss where we gonna have these databases deployed and yeah, if we know already services that we're gonna be using, like cloud services, for example. I mean, I also read an advice like you should not throw random buzzwords in the interview because they can hurt.
Okay, yeah, I think I already threw a couple of them. Yeah, I guess. Yeah, I don't know how LinkedIn operates. I guess also in the cloud, and I mean there are cloud services for everything. So if we take AWS or Azure, there are typical services to use if you need a SQL database. So I think in AWS you have Athena or Redshift. Maybe for this use case it's a Redshift. So I guess it's a typical RDBMS, RDBS. Yeah. If you're talking about like Azure, yeah, they have this Azure SQL, so which is basically Microsoft SQL Server, but managed by them. So yeah, so in general, I mean, this cloud services, they have either transactional database or the data warehouse. So here we don't need probably data warehouse for our purposes.
Can you explain to me so the transactional database, what you mean by that, and the difference also interesting?
The transactional, I mean that if you're like a bank and you have transactions, like someone buys something, these are
so
just
you want to
transactions.
support transactions on that basis level. Okay, that's
yeah. You should be fast for writing them, and then if you need some additional aggregations or actions upon this data, so you need to aggregate like how many transactions per day there were, or to calculate the sums of the money and something like this. Then for this, you probably need.
So why do we need transactions, and what do you think? Why is that important in our system?
Yeah, I just was thinking of this uploads of resumes and job descriptions as transactions. But probably, yeah, you're right, because we don't really need it to be super fast and super consistent as transactions should be. Yeah, I mean, in this case, we can think of some data warehouse solution. actually.
And a data warehouse is like basically a database that doesn't support transactions in opposite to transactional databases. That's the difference.
I think that's how I understand it. Yes, so it doesn't support
Mm-hmm.
anything super fast. So you're not supposed to
Mm-hmm.
write new data and to read it at the same time. I mean,
Mm-hmm.
it's possible, but it's not meant for it. And it's
Mm-hmm.
meant to store a lot of data, maybe a lot of different data aggregations of it, and be ready for uh, queries, like a lot of queries for this data.
Mm-hmm.
Yeah,
Yeah,
and
okay, cool.
yeah,
And it still can be a relational database. I mean,
yeah.
what I have in mind, when you say data warehouse, and it shouldn't be too fast, I have in mind something like S3 bucket for AWS, like just
Mm.
any type of object can be stored, and then it's yeah, they you can read it, but it's maybe not super fast. Is that what we're talking about? Or
No, I think it's like a next stage. So what you're saying about is, I think now it's called data lake or data mesh,
Mhm.
whatever. So when you have just files and you arrange some kind of tables over them, but yeah, it's very slow. And the next
Mhm.
step is to already create tables and to parse these files and to partition them in a proper
Mhm.
way. So they're stored as kind of relational tables in the
Mhm.
database. Yeah, and that will be a data warehouse. And
Mhm.
so, for example, in Google, there's BigQuery, there's Athena in AWS, and I think they are
Mhm.
using like column-based approach. So they try to be kind of efficient in this sense. Um, because in data warehouse you have like probably similar entities which have the same data in many columns, and probably it makes sense to store it column-wise. I don't know honestly why it's
Mhm.
faster. Um,
Interesting. Interesting
yeah.
topic. But that cool that actually you know a lot of stuff about it. I think it helps.
Yeah, thanks. Not sure how it's about system design. Yeah,
Mhm.
if I don't know if trying to get back maybe to this stuff.
Yeah. Yeah. Exactly. Mhm.
Uh, sometimes people kind of discuss APIs or how you can send the data and receive the data.
Yeah. Yeah. That's reasonable.
Yeah, to me, so for example, if you look in here, what kind of APIs could we discuss? Like how we upload the resume, for example, or what would be the API in here?
I was focused on database still. Like, do we want to
Uh-huh. I mean, maybe.
discuss how we scale them
Yeah.
and so on?
Or yeah, good question. Scaling databases. So I mean, if we're using some cloud service like BigQuery, we don't even have to think about it. You just like
Hmm.
fully automate it.
Just
Yeah,
pay money and
yeah,
that's
just
it.
pay money, and you pay money actually. Yeah, you pay for storage and also for queries that you create. I mean, if you do it a bit more manual, scaling. I mean, it makes sense that we always have some additional capacity in the database. So if we need like a terabyte of the data to be stored, that we need at least maybe 2 terabytes of the database to be deployed. It's kind of obvious.
Hmm.
And um, yeah, I mean, when the data grows, we need to scale like probably horizontally. So we need so it doesn't make sense to scale to bring bigger machines and store more data in them. It makes probably sense to just add another machine, so to do a horizontal scaling,
Hmm.
shard the data in between the machines.
How do we shard in this case?
Yeah, so I mean, sharding is just supposed to be that you approximately have the same amount of entities in different shards, and also that you read them in a uniform manner, so yeah, that you always read the same amount from different charts to
Yeah.
make it reliable. And for
Uh,
this, Yeah, I don't know. I think the hash approach is just meaningful. So
I think per region, at least, it would make sense, right? I mean,
yeah. I mean, of course, yeah. Everything that we discuss, it should be done per region. I think. Uh,
mhm,
so all the services should exist in different regions. So if we're talking about resumes in the US, we need to have the
mhm,
servers in the US. And I mean, the
mhm,
users from Europe probably will not query US job applications, or will do it, but in a much fewer amount than US users.
mhm,
Yeah, so this geographical partitioning for sure should exist.
mhm, mhm.
But within the one geography entity, there should be also multiple shards, I guess. Uh,
Yeah. Yeah, it's also just have in mind like I mean we should be fast for active users, but usually when you operate with a resume, it yeah, after a few months, basically you become inactive for some
mm.
time, right?
Yeah, actually, we can maybe think of some other like slower storage in here.
Mm-hmm.
And if the resume is inactive for like 3 months, we can just copy it to a slower storage, and it would be cheaper to store,
Mm-hmm.
less also slower. So cheaper, yeah, cheaper to store and slower to retrieve. So if you will
Mm-hmm.
still need
Mm-hmm.
it, yeah, we will need some time to get it.
And
I
you
mean,
have lots of options in the cloud for that, right? I mean, yeah, you already gave good options for databases themselves, so I assume
mhm.
and you know about that too.
Yeah, I mean, BigQuery does it, I think, by default. If you're not retrieving some table for, I think, 3 months, so you can put this number, they will change the tier of this database and you pay twice less for
Nice,
this. But
nice.
maybe there is some other way.
Hmm.
Yeah. Yeah, that's kind of nice. Are there anything about databases more that we could discuss?
Yeah. 1 second. Yeah, I mean replicas. You touched that in the beginning. I don't know if we can say something meaningful about it at this point.
Mm-hmm. Uh, you mean, yeah. Yeah, well, what I meant that we probably have like one main DB, which inside the DB also might have shards, and we use it
Hmm.
only for reading. That's why we don't need. There are not too many reads. Well, we need to use it for writing. We don't have too many read requests, but we
Hmm.
have a lot of read requests, and probably we need to have multiple copies of our data. And
Hmm.
so this will be like a separate copy, and it's also like there are shards within copies. But then maybe, yeah, maybe there is some like load balancing service between them, and when the user wants to read the data, this load balancing service tells like, hey, just take it from one of them, and
Hmm.
this could be done in in a random way, or how it's called, canary way,
I
when you
know
just
canary releases, but yeah, that's.
wait, yeah, so I think that's a, yeah, that's a buzzword which was
Hmm.
I forgot how it's called. Round robin, sorry, not canary.
Ooh,
Round robin. Yeah.
round robin.
Meaning that you just pick like first, second, third, first, second, third, and so on for
Hmm.
all the
Hmm.
requests. Yeah. And
Yeah, sounds cool. Yeah, actually, another thing I have in mind, and maybe we don't have that much time, so let's keep it on this topic today.
mhm.
Um, Actually, a reading database is an interesting one because we not perform an SQL query when we read in a database here. We just we have to do something else, right?
You mean that we use some kind of ORM library connection to the
No,
database?
no, no, no. Like like some text search, like a full text search that.
In this sense, I actually was thinking that maybe it's a different service. So yeah, you're right. I mean, when we are looking for job, for example, if we're a candidate, we usually type something like software engineer job, and then this there should be a search request, and we have to somehow find the results. But I was thinking of maybe some other service should be handling it.
Then DB for CV read. What it just provides us query
it-
interface for actual data.
yeah, so I was thinking that, so yeah, if you're a recruiter, you like look for data scientists, and then some search service tells you, hey, there are like 500 data scientists, here they are, and some algorithm did it based on some textual data, and then you have the
Mm-hmm.
IDs of these guys, and then you throw these IDs to these DBs, and
Mm-hmm.
you just retrieve information. So here it will
Mm-hmm.
be, I thought of SQL queries. But yeah, how to do the search itself? Uh, I thought that some other service should be doing it. Um, yeah, we
Yeah,
can talk about it.
I was thinking about Elasticsearch. I don't know if that fits here or not. Like, would it help somehow?
Yeah, I think Elasticsearch has an internal like yeah search. Yeah, I think it's a pretty cool tool actually, Elasticsearch. So I think it's able to store the textual data and then retrieve and then perform the full text search based on this data, right? And then I think
Mm-hmm.
you can even like put on top some of your functions.
Mm-hmm.
Yeah. So yeah, I think it's a nice first step. So just put the data into Elasticsearch,
Mm-hmm.
textual data, and then just run these queries upon this data, and it will do full text search. But honestly, to me, that's already maybe a machine learning task.
Mm-hmm.
So I guess so when you're searching for a data scientist, if you're a recruiter, so maybe first thing that you should do is to create an embedding of this data science.
Mm-hmm.
So it's a bit more complicated way, but I think that's what probably LinkedIn is doing. So you have to encode it in some vector, and this encoding might be done in multiple ways. So
Yeah.
uh, yeah, you can
Yeah,
encode
indexing basically, and then yeah, there are a bunch of methods how you keep these vectors. Yeah.
yeah, and then also there are encodings of your current resumes. So
Mm-hmm.
every user should be representing some encoding, and then you
Mm-hmm.
like just look for the most similar users to the search query. So they should be the encodings of the same space.
Uh-huh. Looking at this high-level picture, shouldn't we draw another database, you think, or is gonna be on the
Mhm.
service layer and indeed like
Yeah, I don't know, maybe
and
some
Elasticsearch can be implementation?
search service. Yeah, because to me it's not a database, honestly.
Mm-hmm.
I don't know, Elasticsearch is it a database? Yeah. Because I would probably think of yes this machine learning approach
Mm-hmm.
when you create when you like there are two stages, like one is to create these embeddings and the other is to use these embeddings, and for creating these embeddings it would be enough to have the information about the resumes themselves and who was looking for what. And I
Mm-hmm.
guess yeah, maybe we need to DB for it. Is it so here we probably yeah we don't yeah actually we need probably another DB like something like actions DB. We need to know who was looking for what. Got
Mm-hmm.
yeah, and then these sections DB. So and maybe like file storage. So with resumes themselves, and based on these actions DB, so who was searching for what, and the files themselves, we need to build these embeddings for resumes and also for search queries. And this then
Mm-hmm.
these embeddings are stored yeah either in some in memory database or just in I mean in the service itself in the memory of the service. or maybe there is some small database which helps the service to operate.
All right, Igor, I think
But
that's maybe time to slowly stop. I don't know. So maybe reflect a little bit, like what did we achieve, what we haven't achieved, and
Mhm.
yeah.
I mean, to me, it's still the same. There is completely no structure in my story. Um,
Uh,
I
uh-huh.
we kind of tried to do it in the first when we were discussing user stories, and then functional, some numbers. But then I jumped to some things and I stuck on them, and we start discussing DBs,
Hmm.
and then DBs, and we didn't
Hmm.
even build any high-level architecture of the service. I mean, you can say that this is it, but I think that's not how you should do it. So I still don't
Hmm.
understand how I should proceed on these kind of tasks.
Yeah, but
Um,
yeah, I mean, I think what we did, it's well was structured. We actually followed most of the guides, and some. Yeah, you cannot build everything in 1 hour. That's for sure, right? And we focused on one part of it. I mean, we could continue for like infinite time to build it all, but it's good to keep it on something. But I
mhm,
agree, like maybe a little more practice would also help to build up a story from it. Like, okay, we actually do this modeling, then we discuss databases, and then connected each other, and then yeah, basically we are done. I mean, we done pretty good job in my opinion. Maybe
mhm,
some clue between the lines would be a yeah, next
mhm.
step, let's say.
Yeah, you're right. Yeah, I'm just like there is absolutely no story behind it. So I think when I read the articles, they like, oh, we're building LinkedIn. Okay, so we have the user, they
Mhm.
send a request, the system, then there's something happening, and then they start drilling down what exactly the request is, what are the services inside, and it always looks like a real story. Um, yeah, I need to practice. Yeah, I also need to watch a bit more of this because I don't know when I talk about machine learning service, let's say like how to
Uh-huh.
if we would have talked about how to build this matching service, then I would have like some story in my head. I would know like what building blocks we need, what data we might need, what services we might use, and so on. But
Mhm.
yeah, actually, this educative FIO, uh,
Yeah,
yeah,
it's very useful articles there. Yeah.
yeah. I think that it's in the
Okay.
course, right?
Yeah, some indeed some proposals. I mean, the one that you don't have to apply for this one, for example. Can
Mm-hmm.
you also share a link maybe to this design somehow? I don't know if that's possible with the Excel drawing.
Load, wait, export, save as image. Yeah, export link.
If you don't
Okay,
mind, of course. I mean, I
sure.
think it can be useful for our followers.
Yeah, let me, maybe I put it to the private chat and you can copy
Yeah,
because I think I don't
sure,
have
sure.
access. Oh,
Ooh,
well, no, wait.
wow.
Uh, is it? No, I guess I didn't copy it properly. Yeah, that's something different, sorry.
Yeah, it looks like a password to your bank account, actually.
It has something about Excalibur, so I'm not sure. I think that's maybe like some rectangular. Yeah, it's a rectangle.
Well, thanks a lot again. I think it was super nice, and let's see in the next sessions.
Yeah, yeah. Thanks for guiding me. Maybe in a more if we do it like 50 times more, I
Hmm.
I will be able to do it better.
All right.
Let's see.
Have a good Saturday, everyone. Have a
Yeah.
nice weekend.
Thank you. Yeah, you too. Cheers, everyone. See you next time.